Okay, in this video, I'm going to detail CGA graphics in a very simple way, and I wanted to talk about this before we get into assembly language and CGA graphics. One of the reasons why games were made in assembly language in these days was because assembly was fast and much faster than what you might be able to produce with C unless you have some inline assembly routines to make it faster. I'll give you the example. If I'm gonna do this, let's do bgraph.basic. This program will show the source code for drawing on CGA using BASIC. And there's a reason for me showing this. It's very simple. I have a loop from x equals 0 to 319, and then here's the line function. And when it draws, this is the interpreted version, so you can see it's going pretty slow. But I do have a compiled version, one that was made with Power Basic and one that was made with Quick Basic. First, the Power Basic version. We'll call this bgraph. And it seems to be just as slow as the interpreted version. But don't knock it. There are other drawing routines that run much faster in Power Basic rather than the simple line function. And this is the line function in CGA, which, believe it or not, is different than what you might expect in MCGA. So that's one of the reasons why it seems so slow. It's to say that it's slow because of BASIC is oversimplifying the problem. Now, to show you the bgraph function as compiled by Quick Basic, it's still a little faster. You might notice it, but I'm running this real time. You can compare the two and see what I mean. But this is a little faster. Finally, the C version. So let's load up QC graph, which I had named. And when this loads, you'll see the program is very straightforward. I only have a few headers here to do the line drawing, which requires the graph header. Then I use time and the standard lib for the randomizer because I wanted random colors in there. But otherwise, the real work is being done here in this for loop, where I have a set color, and then I have the move to, which points the starting pixel for the line, and then the line to will graph from the starting pixel to the end of line, which is this right here. It's similar to Quick Draw if you worked with Mac or Apple back in the day, and just like Quick Draw, it's good at drawing, but it's not exactly quick. But it was good for the time, and much faster than you might get with BASIC, obviously. But it works. But the reason why it's slow is because internally, what's going on with CGA is that the graphics are interlaced. Every even pixel on the horizontal line is in a slightly different offset group than the odds. So evens and odds are separated into 8K chunks in the memory segment, and this is why it goes so slow, even though the C function is considerably or noticeably faster than the basic anyway. So let's run that, and you could see just how much faster that is, which is impressive, but it could still be faster with assembly language. And in the next video, that's what we'll be doing. We're going to write a routine in assembly language to do the same thing. And the purpose of doing that is you'll notice that there will be a V-line function that will need an H-line function for a horizontal line. And then finally, we will design a arbitrary line that using an algorithm, maybe Brissenham's algorithm, to do the line. But anyway, the point is, the purpose is to show how to structure your code for these different types of lines, and it'll be significantly faster for H line compared to V line and finally the arbitrary line, which you can do with assembly language. You can write a C routine as well, but the whole point is if we're going to be working with original hardware, there will be some other caveats that I'll be pointing out when we get to that point. So hopefully this helps and get you started in graphic programming for MartyPC. Thank you.